He spent his entire life believing eye color was just an aesthetic detail, until he realized that might be completely wrong. What if someone told you your eye color wasn't designed to be beautiful, but to keep you alive? It sounds exaggerated, but the truth is even more unsettling. What you see in the mirror may be the direct result of brutal evolutionary decisions shaped by intense sunlight, low-light environments, and even unconscious choices of attraction. More than 70% of the world's population has brown eyes, not by chance but by necessity. The other 30% exist because of relatively recent genetic mutations, almost like experiments that happen to work under specific conditions. And here's the surprising part. Some of these variations appeared before other human traits we now consider fundamental. In other words, this story isn't linear, and it's definitely not obvious. Now here's what changes everything. Each eye color can reveal where your ancestors lived, how they survived, and what challenges they faced. This isn't about aesthetics, it's about adaptation. And once you understand that, looking at someone or even yourself will never feel the same again. Because the question is no longer, what color are your eyes? But what did they have to endure to exist? Brown eyes. He may have never thought about it, but brown eyes carry one of the most efficient evolutionary strategies ever developed by the human body. The high concentration of melanin isn't there by accident. It acts as a natural shield against intense sunlight. In regions near the equator, where the sun is relentless, this protection could mean the difference between clear vision and compromised survival. In some contexts, seeing better literally meant living longer. In practice, melanin absorbs up to 90% of incoming light, reducing glare and improving visual comfort in bright environments. Imagine someone walking under the harsh African sun thousands of years ago, while others struggled with the brightness. Those with brown eyes could stay focused, detect threats, and hunt more effectively. Even today, this shows up in simple ways. People with darker eyes tend to handle bright conditions better, like driving at noon or staying under strong lighting for long periods. And there's a detail many people misunderstand: those golden or amber reflections that appear under certain lighting. No, the eyes aren't changing color. It's just a physical interaction between light and melanin. Still, this subtle visual effect has fascinated people for centuries. But while all of this worked perfectly in bright environments, something very different began to emerge in places where light was scarce. Blue eyes. At some point in history, something unlikely happened. A silent mutation in the HERC2 gene completely changed how melanin was distributed in the iris, and suddenly the first blue eyes appeared. What's most fascinating? Every person with blue eyes today shares a common ancestor who lived between 6,000 and 10,000 years ago. It's as if this trait is a genetic signature that spread across the world. Contrary to popular belief, blue eyes don't actually contain blue pigment. What we see is a light scattering effect, similar to what makes the sky appear blue. With little to no melanin, light disperses differently, creating that distinct color. In low-light environments, this may have offered a subtle advantage: increased sensitivity to available light. In northern regions with shorter days and overcast skies, even a small visual edge could make a difference. But survival isn't the only explanation. There's a widely discussed theory that rarity itself helped spread blue eyes through sexual selection. In simple terms, what is rare draws attention, and what draws attention often gets chosen. Interestingly, light-colored eyes appeared before light skin, raising new questions about how these traits evolved together or independently. Gray eyes. If blue eyes are rare, gray eyes are even more unusual. Found in less than 3% of the global population, they carry a unique characteristic: even lower melanin levels than blue eyes. This changes how light behaves in the iris, creating that metallic, almost cold appearance that seems to shift depending on the environment. Physically, gray eyes result from a broader scattering of different wavelengths of light. Instead of reflecting a single color, the eye creates a complex visual mix that the brain interprets as gray. In low-light regions, this may have provided some advantage in capturing light, but with a trade-off: higher sensitivity and vulnerability to UV radiation. Over time, gray eyes became associated with traits like emotional control, mystery, and coldness, not because of biology, but because humans tend to create narratives around what they don't fully understand. And when something is rare, it naturally feels symbolic. Green eyes. Among all eye colors, green stands out as one of the most enigmatic. Not just because of its rarity, around 2% of the population, but because of its genetic complexity. Unlike blue eyes, which trace back to a single mutation, green eyes result from the interaction of more than 16 genes. This combination creates one of their most fascinating traits: visual instability. Depending on lighting, surroundings, or even clothing, green eyes can appear lighter, darker, or slightly golden. It's not that the color changes. It's that light interacts differently each time. From an evolutionary perspective, this may represent a balance between protection and light sensitivity. Throughout history, this rarity has been linked to mystery, intuition, and even magic. Not because of biology, but because of perception. Hazel eyes. Hazel eyes are perhaps the hardest to define. At first glance, they may appear brown, but under different lighting, green and golden tones emerge. Unlike other colors, this isn't just perception. It's a real variation in how light interacts with mixed pigments. This comes from a complex genetic combination of melanin and other pigments like lipochrome. The result is visual versatility, which may have offered adaptive advantages in environments with changing light conditions. Instead of specialization, hazel eyes represent balance and flexibility. This constant variation gives them an almost unpredictable quality, something that has long captured human attention. Amber eyes. Amber eyes look like they've captured sunlight itself. Golden, intense, and unmistakable. Found in less than 5% of the population, they maintain a stable color due to high levels of lipochrome and low melanin. Interestingly, this color is common in predators like wolves and owls. While there's no direct behavioral link, humans instinctively associate it with intensity and focus. Evolutionarily, amber eyes may not offer a clear survival advantage, suggesting they may have spread more through attraction than function. Sometimes, evolution preserves what stands out, not just what works. Very dark, almost black eyes. Many people believe black eyes exist, but in reality, they are extremely dark brown. The high melanin concentration absorbs nearly all incoming light, creating that deep, uniform appearance. This provides maximum protection against UV radiation and reduces visual strain in bright environments. It's especially common in regions with intense sunlight, like Africa and Southeast Asia. There's also a psychological effect. These eyes reveal less internal contrast, making emotional cues harder to read, adding an element of mystery. Heterochromia. Just when everything seems predictable, heterochromia breaks the pattern. A rare condition affecting less than 1% of people, where eye colors differ either between both eyes or within the same eye. This happens due to uneven melanin distribution during development. It's not necessarily an advantage or disadvantage, but it creates a striking visual uniqueness. Historically, it has been linked to the supernatural, simply because it defies expectations. After exploring all these variations, one thing becomes clear: we're not just looking at colors, we're looking at history. Each shade carries traces of migration, climate adaptation, and survival. Eye color is more than appearance. It's a biological record of human evolution, a silent story written over thousands of years. And maybe the most fascinating part is this: every person carries that story without even realizing it. So the real question is, what else is your body trying to tell you?